I'm Evan Lewis on the Evan Eascent channel on YouTube, and you may be wondering why we're starting this episode with a car fuse blowing, and you'll soon see why. The project is to make a loud clicker. So because I'm having difficulty hearing the indicators, the traffic indicators, when I'm about to turn a corner, especially if I'm on a rough road with the engine making a lot of noise or with noisy car tires. It's just a little bit too faint for me to hear well. So I decided to make a loud clicker. I tried to get access to the internal clicker in the car dashboard, but it was too difficult to get to. So I decided to make my own clicker. And this is a project. This is the device we ended up with. And it's got a coil inside, which you might be able to make out there. And that coil is an electromagnet which pulls on a metal plate that makes the clacking noise, and it's got a switch just to turn it off if you don't want it. And that's it. This is very similar to a conventional relay that you would find in a car, and this model has a clear plastic cover, so you can see on the right hand side that there's a copper coil. This has a soft iron core in the middle which becomes magnetized when electric current runs through the coil. This magnet then pulls down a metal plate which operates a switch, and on the left hand side you can see a double pole double throw switch setup. So that's a relay. The difference with this device is that it has a very large number of turns of very fine wire on the coil. This produces a high resistance, which is necessary if you're going to apply 12 volts to it. You want to restrict the amount of current that goes through. The amount of magnetism that's produced is proportional to the number of amp turns, that is the number of turns of wire multiplied by the number of amps flowing through it. So this has a small number of amps and a large number of turns. We're going to do the opposite. We're going to use a small number of turns with fairly high amperage going through it, actually up to about 7 amps. And that'll produce a similar magnetic field, but with a different coil design. To do that, we'll need to use a thicker wire to carry the heavy current. Here's a circuit diagram to show how it's all set up. The green box at the bottom is the car fuse box, where the fuse number 13 on this car is the one that supplies power to the flasher unit or hazard lights. And here we're using a blown fuse, marked in yellow here, so that we can tap into the car's circuit. On the right hand side of this yellow fuse, we find there's a 12 volt signal, which we then pass through our circuit. And we include the red fuse, which is intact, since we don't want to run the system without a fuse. The power comes from that fuse to the right hand side to the coil, passes through the coil, and then back into the other side of the fuse. So the power that would normally go through the fuse is redirected to go through the coil instead. However, if we don't want to use that system, we can close the bypass switch, and then the power goes straight through that bypass line and back to the yellow fuse without going through the coil. That just turns the clicker off. Alongside this switch we've got a diode. The reason for that is that when current does pass through the coil, it magnetizes the soft iron core, and then when the flasher turns off, the current stops and the electromagnetic field collapses, and that generates an electrical pulse in the opposite direction, which could go through the car's circuit and cause damage to your computer with a power surge. And to prevent that, we tap off the power going in the wrong direction with this diode. So the diode is like a one-way valve. It lets current go through one way but not the other way. So when it gets a reverse polarity, reverse voltage going through, it leaks it out through that diode, and then it's safe. In this clip we'll see measurement of the current going through this fuse. We take the fuse out of the fuse box and put probes in there and measure how much current is passing through fuse number 13. So I've just got one blinker going now, and it's going up to 3.5, 3.80, 3.80, 3.80, 3.80. So that's the blinkers going on and off. It doesn't show very well on a digital meter, but you can see it going on and off like that. It's only 3.8 amps. If I put the hazard lights on, so all four corners of the car are flashing. So now it's going to 70, 70, 70. So I want to make a little electrical coil to put inside this box, which is going to be its case, and it's about 33 34 millimeters wide inside. And so I'm just going to cut a piece of plastic that's about that size and turn it down a little bit smaller. So I'm going to make this into a round piece. I'm not sure where this piece of plastic came from. It's very brittle. I was going to steal one of my wife's chopping boards, but lucky for her, I found this piece of plastic. So it needs to be an insulator that I can wrap the wires around. So plastic is ideal if you can get something that's you're able to turn. This is, as I say, it's a bit brittle, but we'll see how it goes. So this has to end up being round, so I'm going to chop the corners off, approximately. Actually, before I do that, I should find the centre. That's easiest if you've got corners on it. So I'll draw a line across here from corner to where the corner was originally. And another one the other way. So there's the midpoint, centre point. Yeah, that's what I'm going to have to do to hold it in the chuck on the lathe. Is I'm going to have a hole through there with a bolt through it. That's a little bit less to chop off with the lathe. So then I'll take it to my drill press. If I put a 6mm tap through there, it may be easier to hold that way anyway. So I'll put a 5mm hole through here. I've got a set of 3 taps here. They come with a taper tap, intermediate tap, and blind tap, or number 3 tap. So some people will just call them 1, 2, and 3. I call them taper, intermediate. Let's just take it right here. Taper, intermediate, and blind tap. So I ran the taper tap through first. So it's a 6mm thread. It needs a 5mm drill, which we just drilled. Ran that tap through. Run that through. Sometimes the blind tap is a little bigger than the taper tap, especially when you come to very large taps, they do that. And you don't get the full depth of thread until you put the blind tap through all the way in and back out again. So that's now threaded. So now I've got to find a 6mm screw that I can put in the chuck to hold this. So what I want is 6mm M6 screws, and there's some stainless steel ones, they'll do. So we'll get those down. I'll close the cupboard doors again so I don't bang my head, which is what I usually end up doing. Yep, looks about right. Tie it up pretty tight because we don't want that spinning around in the lathe. As I say, I've turned this plastic before and it tends to be rather brittle and cracks and splinters, so we'll see. Turn the power on. Fairly firmly onto that thread, I don't think we'll damage it. Earmuffs, glasses, watch off, netting ring gone. I do most of my work with a silicon carbide tip, but I'm thinking that I'd be better off with a really sharp high-speed steel tip with a good rake on it. We'll take this off, put it back on my rack, and this is where I hang the camera, so let's put that up there. So here's my high-speed steel tool, which I plan to use here. I think it may cut better than the... oh, it's back to front. It's fairly sharp, but I've got an oil stone here. Give it a bit of a rub with 3-in-1 oil. Get all the three faces. And a bit of a rounding on the end. That's where the cutting happens actually. Okay. It hasn't got a particularly high rake on it, but I think it'll be good enough. I've got a strip of copper that I happen to use as a spacer under here. I'll put the key away on its rack. Clamp it down. And I think we're about ready to go. Still flat there. Okay, so I'm not going to cut a groove in the middle to make it into a like a spool for winding some wire onto. Nice soft swarf. You can't cut yourself on it, that's for sure. Yeah, it's got to go in a bit deeper. Trouble is you can't see what you're doing with all that swarf, and plastic's really bad for making all that. For this side, now I've got to clean up that corner in there. I think I'll just use my ordinary silicon carbide. It's going to go at least part of the way in. We'll see how it goes. Okay, we don't need to get too fancy here, but I want to have a hole in here to get the wire through. So now I need to choose some wire. I think if we spin the camera around a bit, you'll be able to see. Several spools. I've got some very thin wire. We put a lot of turns on with that, and several other plastic coated wires. They're no good for making this coil. Well, you could use it actually if you had to, if you had nothing else. But I've got this proper coil winding wire here. I want this to turn very slowly, so I think I'll put it in back here to guarantee slow speed. Put the wire through. Actually, I'm going to need, let's go forwards. Well, they haven't been counting turns, but that looks like enough to me. I should have drilled a hole up at this level to bring the wire back through, I suppose. So that's the main part of the coil. Now the next thing we have to do is put an iron core through the middle, so I have to make that next. So I'm going to have to drill a hole through the middle, big enough to take an iron core. We need soft iron, so I usually use this old bolt. Take it out of back here. And I'm going to make a hole through the middle there. I haven't decided how big yet, but then I'll turn the iron core down to the same size. One of the little boring bars. Actually, it's 15.59, nearly 16 millimeters. .65. Let's go back to our silicon carbide tips. Moving. Okay, it's just firm on that end. So I'll make that the depth. There. That's probably about right. This piece has to fit inside the square hollow, fairly close, probably about 3 or 4 millimeters from the top. Yeah, so just take another couple of millimeters off this and clean it up. So, now we have the coil fitting neatly on there, and a little bit of the metal sticking out the top. It's about right.